Hello everybody, welcome to my YouTube channel. In this video, we'll learn about statistical inferences. This is the part 2 of statistical inference. Part 1, if you haven't seen, please see it, then proceed to this part. In this part, we'll learn about hypothesis testing and significance level. So, the first thing is hypothesis testing. Let's take a scenario. Suppose this is Tom and he is taking a population. He's researching on a population, and he's researching on the age of the total population, and he believes that the population mean age is 50. Then he takes a sample and he finds out the sample mean to be 20. Then he assumes, then he hypothesizes that the total population mean is somewhat more than 50. So what is hypothesis testing first? We'll know, then we'll understand what is Tom trying to do. So hypothesis testing refers to making an assumption called hypothesis, collecting a sample data, calculating a sample statistics, using the sample statistics to evaluate the hypothesis. To test it tests the validity of your assumptions. You determine the difference between the hypothesized parameter value and the sample value. In a nutshell, it's a claim what you want to test basically. So there are two components of hypothesis testing. There is null hypothesis and there is alternate hypothesis. What is null hypothesis? It states the hypothesized value of the parameter before sampling the assumption we wish to test actually, or the assumption we are trying to reject. So Tom believes that the population mean age is 50. That is the null hypothesis. What is alternate hypothesis? All possible alternatives other than the null hypothesis is called alternate hypothesis. Suppose mu is 20, or mu can be greater than 20, or mu can be less than 20. So what Tom thinks that the total population mean is somewhat more than 50 is the alternate hypothesis that he takes. So the significance level is the probability of rejecting the null hypothesis when it is true, which is known as a type 1 error, and it is denoted by alpha. So now what is confidence level? The confidence level is just the complement of significance level, which signifies how confident you are in your decision, expressed as 1 minus alpha. So let's see how we can interpret the significance level. So deciding on a criterion for accepting or rejecting the null hypothesis. Significance level refers to the percentage of sample mean that is outside a certain prescribed limit. For example, testing a hypothesis at 5% level of significance means that we reject, first thing, we reject the null hypothesis if it falls in the region of area 0.025, and do not reject the null hypothesis if it falls within the region of area 0.95. The higher the level of significance, higher is the probability of rejecting the null hypothesis when it's true. So how do we compute the significance level? There are two ways of calculating or computing the significance level. One is one-tailed test and the other is two-tailed test. So first, let's see what's one-tailed test. A one-tailed test is a statistical test in which the critical area of distribution is either greater than or less than a certain value, but not both. So here in one-tailed test, either this can be this part or this part, not both at a time. So here it is greater than a certain value. It's greater than here's the normal probability. It's greater than the normal probability. It's right shaded area, and this is the area that we take in one-tailed test. We can take this area also in one-tailed test, but not both at a time. While when we take both at a time, it comes under two-tailed test. So we'll see what is two-tailed test. Two-tailed test is a statistical test in which the critical area of distribution is two-sided. It's in both the sides. It tests whether a sample is greater than or less than a certain range of value. It tests both the sides, actually both the tails. That's why it's called two-tailed. If the sample being tested fall into either of the critical area, the alternative hypothesis is accepted instead of the null hypothesis. It is appropriate to say when null hypothesis is equal to mu0 is equal to mu1. So alternate hypothesis, when we take mu0 is not equal to mu1, then we use a two-tailed test. So to understand two-tailed tests, let's understand it with an example. We'll get a better view of that. So a machinist is making an engine part with axle diameter of 0.7 inch. A random sample of 10 parts shows the mean diameter of 0.742 inch with a standard deviation of with a standard deviation of 0.04 inch. On the basis of this sample, would you say that the work is inferior? So the work is not inferior is taken as H0. We'll see in the further. So given size n is equal to 10, which is less than 30. So we'll take small sample tests, not large sample testing. Here the sample mean of is 0.742, which is the mean diameter. What is the population mean? Is the axle diameter, that is 0.7 inch, and the standard deviation as given is 0.04 inch. Here we want to test the difference between the sample mean and population mean. So we just apply, we have to see the two differences, so we have to apply t-test for a single mean. So H0, as I said, is 0.7. Null hypothesis is that the engine parts, there is axle diameter is 0.7 inch, and H1 is mu is not equal to 0.7. So here we see we have to use two-tailed test. We have to take both tails. So under H0, the test statistics is T is equal to mean minus mu by sigma upon root over of n minus 1. So solving it, we get T bar is 3.16. So calculated T is 3.16. So LOS is alpha is 5%, and tabulated value of T of 0.5 is 2.26 that we got from the table. So it's 2.26. So what do we infer from it? So here we see the calculated T value is greater than 2.26. So H1 is accepted. That is H0 is rejected at 5% level of significance. So the work here is inferior, that we infer. Thank you for this, and please subscribe to my channel, and for any doubts please publish your doubts in the comment section.